I'm Michal Mocny. I work for Google on mobile web stuff. And in particular, the last couple of years, I've been working on hybrid application development, partially with Chrome apps for desktop and partially with Apache Cordova, helping to contribute to that. And so I'll be discussing the symbiosis between those. So, what are Chrome apps? A lot of you know. That's fantastic. I will review. What is Apache Cordova? I'm sure a lot of you know that, but I will review. And then what has my team been working on to bring those two together? And then sort of a second part of this talk will just be hybrid apps in general and what's changed and what's awesome. So what are Chrome apps for those who don't know, or review for those who do? So a quick video. So this is me using my Chrome browser to go to the Chrome Web Store. Much like there's the Play Store for Android, this is a website, but it's a sort of privileged website that has a large list of applications that people have uploaded. And I'm going to look for an app called CIRC, which is an IRC application. And this is a new Chrome package app. And so, as you can see, star ratings, reviews, that sort of thing. So at this point, I've closed my browser, and I'm using something called the Chrome App Launcher. Oh, let me get rid of that. Which has like user switching. It's sort of in the menu. Let me see. There we go. So I'm switching users. There's my list of applications. It's like a start menu for Chrome apps, and I've launched CIRC. And at this point, it's like a standalone window. In the top corner, you see it says CIRC. There's no Chrome UI anywhere around there. And it's using raw sockets to connect to real IRC servers. And so at this point, I've connected to Freenode, and I'm joining like Cordova channels. I've set my nickname, that sort of thing. So something you would have typically done with a native application in the past, or a web application using a tunnel, you can now use as a standalone app. So awesome. There's a member list, and I can chat. Hello, everyone. So this is an example of a Chrome app, all built using web technologies. And if I Alt-Tab, it's in the list of Alt-Tab menus with its own icon, and I can switch to it. If I search Spotlight for CIRC, there you go, it's in the list. So it's got like really good native integration. Feels more like an app than it does a website. All right, that's enough of that. So hopefully everybody knows more or less what a Chrome app is. So, reviewing. Chrome apps are packaged and installable. This means, once you're done developing your application, you zip up all the contents, you upload them to the Chrome Web Store. Users then download that whole application package, combined with screenshots and icons and everything you need, and they install it onto their device. As you saw, native platform integration, the icons, the Alt-Tab switcher, the menu bar at the top, it really feels like an app that's part of your platform. These apps have device capabilities that were typically reserved for native apps. You have raw sockets, as IRC did, but you also have Bluetooth access, you have USB access, you have rich notifications that display inline that look really good. Chrome apps are offline by default. This is partially to do with the fact that they're packaged and installable. You have everything you need to run your application. You can, of course, communicate with servers if you would like to add extra functionality. But much like a native application, the base of your application is there. The second more important reason why they're offline by default is even if you're using app cached or any other strategy to cache your application, if you're hosted on a URL, users aren't going to reach for it. They're accustomed to knowing if they're in airplane mode with their device, they can't use the web. They can't use the browser. There's no point. With packaged apps, they're ripped out. They have icons. They're integrated into their system. And so if they try it once and they'll see that it continues to run, they will continue to do this. And we see this pattern. And so sure, CIRC won't actually be able to connect to the server, but the app will start and it will give you a nice error. Other applications, like photo applications, will work just fine. Chrome apps will auto-update just like Chrome auto-updates under the hood. Anytime you upload a new package to the Chrome Web Store, all your users that are signed in across all of their devices will get the new version automatically. They work on all the major desktop platforms, written with these awesome technologies. And this is sort of what it looks like to create a Chrome app. There are two required files, and the rest is sort of up to you. And it looks very much like typical web app development. So this is a web app manifest, or a Chrome package app manifest, very similar to the new web app manifest spec. But you just give it a name, a description. There was a previous version of packaged apps, and so this is just saying that this is the second version, the new one. A background script. So the first thing to start in your application is a persistent script, which can be loaded on demand without even application windows, so even if the user doesn't click an icon. So you have to specify which JavaScript file to start. And then a set of permissions, which the user will be notified upon install if they would like to allow your application to use these permissions, such as notifications, GCM, etc. So this is this background script. And it has, its primary role probably is to register for all sorts of system events. On launched is when you click on an icon. But you also have GCM on message, so when there's an incoming cloud push message that arrived, or a user clicked on a local notification that you opened up earlier. And these events will fire even if your application windows aren't open. Sorry. So in the on-launched event, you probably want to create an application window in response to that, and you can create one unique window which will be brought into the foreground, or multiple windows, that sort of thing. It's up to you. And that window that you create is just a regular HTML page. You go from here, take it wherever you like. OK, so closing thoughts. Chrome apps are not a replacement for websites, for hosted websites. They're not easily linkable, and that's one of the most powerful features of the web. They're not ephemeral. They need to be installed. And this is annoying for many reasons. And I said that they auto-update, but you have to still, like manually upload a new version. You can't as easily A/B test. You can't do a lot of things quite as easily as web apps. But they're a serious alternative option to native apps written in, say, C++. So as much as I do love writing C++, and I do, there's a lot of things that go along with that, a lot of baggage. And with Chrome packaged apps, you have simplicity, especially if you're already a web developer. You have security. Chrome has a fantastic track record for security, and Chrome apps run in an even heightened sandbox. And so you could just start with the assumption that you'll be relatively secure, as opposed to starting with the assumption that you won't be. You get distribution through a store, which is actually, this is the trend for even native apps going forward these days. But yeah, now you can do this with web apps. Auto updates, error reporting, analytics. Like, there's so many things you have to build if you're running a native app. Chrome will do delta updates, very low amount of bandwidth in the background without users ever thinking about it. Once they install your app, they're always up to date and they don't need to think about it. These are not traditional things that native developers have had automatically given to them, although the trend is changing. And error reporting, analytics, all these things happen through the dashboard. So it's pretty cool. OK. So those are Chrome apps. What is Apache Cordova? I'm assuming a lot of you do already know, but it also goes by PhoneGap. That's the Adobe branded version of Cordova. Cordova is the open source Apache thing. So let me show an example of a Cordova application. So this is me going to the Play Store to install Untapped, which is one of the most popular, more famous PhoneGap applications. And it's a social network for beer, which is just awesome. And 500,000 downloads and 4.3 average star rating, which is pretty fantastic for any application. And this is what Untapped looks like. And it does look a little different. It's very colorful. The widgets are a little different than other applications, but users love it anyway. They get to drink beer, and so that's all that matters. It gives them what they need. So it's a very popular application, and it has access to a whole bunch of native device capabilities and native device integration, which is what they needed to get their job done for them. Okay. So that was running on Android, but it will also run on iOS. One more. OK, so Cordova applications are packaged and installable. You also build your whole application, wrap it all up in a native wrapper, and upload it to the store. And users will pull the whole thing. They also have native platform integration. They're I showed that we went to the Play Store to install the application. There was an icon on the home screen. If you go to the switcher, you could see the application. It's not part of the browser. They have native device capabilities. You have access to all of the Android and iOS APIs wrapped in Cordova plugins to make it really easy to call from JavaScript. They're offline by default for all of the same reasons. They auto-update because Play Store will auto-update and Apple App Store will auto-update your applications. And they run on Android and iOS. So these are, I should add more platforms here. Cordova applications will actually run on a whole bunch of mobile platforms, including BlackBerry, Windows Phone, Firefox OS, etc. I list Android and iOS because those are the ones that are used by the Chrome team. So they're written using these awesome technologies. So, reviewing. On the left you have Chrome apps for mobile. On the right you have Apache Cordova. So we fed this data into Google's machine learning system, right? It crunched the numbers. It took a little while, right? We sort of thought, what's it going to come up with? And, it came up with this conclusion. We saw the pattern. So about 2 years ago, we got together and we thought, well, hybrid apps are extremely popular on mobile platforms, and a lot of people gripe about how poor they are for a lot of the wrong reasons. And so we thought, well, can we help learn from and help improve, especially Cordova's core offering as the #1 most popular hybrid application platform? And can we create an emulation layer to run Chrome desktop apps on mobile? There's no way you're going to run a Chrome app on iOS natively. And at the time, there was just no bandwidth for us to also add the same thing on Android. And it was unsure if we wanted to do that anyway. 2 stores, it doesn't make sense. So we thought, can we just write real Android apps? Can we write real iOS apps, but that can be written as if they were a Chrome app and that sort of thing? Can we re-implement all of the APIs mapping to the native APIs as Cordova plugins? And can we improve the workflow for hybrid development to be as awesome as web development is on desktop? So this is an example of what we've built. This is an application called Topeka. Is this video running? Come on. All right. So this is a notification that has come in from a GCM message to say, hey, somebody's beaten your score. Now, Topeka is a quiz application written in Polymer. It's extremely colorful. It was done for Google I/O to show off material design. And this is all web. And it looks fantastic, and it runs absolutely smoothly on a Nexus 4. Topeka is just a web app that could be run hosted, but it doesn't have access to push messages or native notifications. And I sort of missed the video at the start, but this tracks your score and it uploads to the server. And so if anybody beats your score, you'll get notified, and it will say, hey, you should play some more, answer some more questions because you're falling behind in the standings. So it drives adoption. And so, yeah, this is now in the Play Store. Last I checked, I think there were 20,000 downloads, and we just uploaded it a little bit ago, and very good ratings. A lot of our negative reviews come from not being internationalized, our bad. So this is the first day it was uploaded. It's now been up for a while. All right. So that was an example of just a colorful app that was built as a Chrome app and uploaded to the store. So you can learn about mobile Chrome apps. It's all open source. It's up on GitHub. And then Chrome apps for desktop is the lower URL, and that will teach you all about the APIs and the structure of the application. You can learn more. So another thing that we wanted is to improve the development workflow. So for Chrome apps for mobile as opposed to Cordova development, we have a few tools that we use that I want to show off. So you actually have 2 options for developing Chrome apps for mobile. The first one is sort of the typical Cordova workflow. For anybody who's done that, they probably know what this looks like. And this is sort of a command line interface. You build an application template, you compile the whole thing, you update your web assets, you re-prepare to move everything into the template, build an APK for Android, that sort of thing, and deploy it to your device. It takes a while. It takes many seconds each and every time. But you can, eventually you have the full artifacts you need to upload to the Play Store. So eventually you're going to have to do this. You also want to do this if you're hacking on the actual application template. If you actually want to be writing Java and Objective-C alongside your web code, then this is what you want to be doing. And we have a tool called CCA, that's Cordova Chrome Apps, that's up on NPM. And that's what you want to use. The interface is very similar to Cordova CLI for anybody who's done that, so for iOS and Android development. But there's a second option, and that is we have built an application shell that runs on your mobile device, and you can just push just your web application assets over. And so you get sort of this edit, refresh workflow just like you would in the browser, except to your mobile device with platform APIs, all of the Chrome APIs. And you can build this yourself, and you can customize the plugins, but we've already built one for you that you can just install, and that's called the Chrome App Developer Tool for mobile. There is a Chrome App Developer Tool for desktop, which helps you develop Chrome apps on desktop. So just be sure you get the right one depending on what you're trying to do. It's also open source. It's on our GitHub, so you can go get it there. There's all instructions on how to install it. So at this point, I usually do a demo, but today will be a demo video. I do not want to tempt gods. So again, using the Chrome App Launcher to launch something, the Chrome Dev Editor, which is a Chrome app for developing Chrome apps. Whoa. And you just saw me creating a new project, and it has templates, so it's boilerplate for all sorts of things. You can create regular web applications, but in this case, I'm building a Chrome app that is not using Polymer, not using Dart, but it has a whole bunch of different boilerplate. That was me running it locally. I didn't like the default application it provides, so I'll just change it minimally. Oh, and I almost forgot to put the smiley face in, so there it is. OK. Very simple default application. So it has a deploy to mobile option. Now, I couldn't get in this video what my phone was doing. Usually, I could look on my phone. But I've now deployed to mobile. And using Chrome Inspect, I can open a remote inspector. So that is what was on my phone. So for anybody who doesn't know, Chrome DevTools now has mobile emulation, including if you have a connected mobile device, it will mirror. So that is what my application looked like on my phone. And so now I can make an edit in Chrome Dev Editor, if I could do CSS properly. And I can redeploy it to mobile. And so it's kind of annoying to like drop down, deploy to mobile every single time. So there's a live deployment option. And what that means is every time you make a change locally, and Chrome Dev Editor will auto-save, it will automatically redeploy to mobile. So I changed the background to red, but let me pick another color I like. Oh, that looks good. Copy that. And I'm going to paste that back into the Chrome Dev Editor. And it will automatically redeploy, which it did, but it's the same color because I just pasted it. So let's actually change the color so you can see redeploy in action. OK, so at this point, I didn't do anything, and it redeployed. Now, I'm just fidgeting in DevTools because there's a bug right now where the change is done on the phone, but you have to fidget with it for it to reset on in DevTools, and they'll fix that soon. So yeah, and final demo, you always have to show an awesome API that you can do inside of a WebView. So this is me using the camera. This was me earlier. If it was a live demo, I'd record you guys. But anyway, so that's it. So that was just iteration. You make a change, it redeploys. If you want to use DevTools to inline edit CSS, you can. You can also do all sorts of debugging. OK. So Chrome apps for mobile have a few really cool APIs that will work across desktop and mobile. So GCM is cloud messaging. That's push messaging. Rich notifications with buttons that do things, and images and lists and all sorts of things. Socket and the new Sockets API, there's two. Including you can run a web server on your phone written in JavaScript, which we do, and it works quite nicely. UDP, multicast, a whole bunch of stuff. Chrome Identity is just making OAuth flow much simpler. It's trivial. It's like, who are you? And it figures it out. And on iOS, it will use a Webflow, but if you have Google Plus installed, there's a native SDK to authenticate with that account. So it's got this really nice flow. On Android, it will use the Android account switcher. And on desktop, it's whatever account you're logged into Chrome with, which is a requirement for installing apps. And so you'll get a user account. And then all sorts of other things, and then anything else that Cordova supports. OK. So that was Chrome apps for mobile. We're doing a workshop tomorrow. If anybody hasn't signed up just yet, come check it out. It's a 4-hour workshop, and we'll go through how to get set up, how to get running, and we're going to build this really awesome app called A. I'm a Canadian, eh? So for the rest of the talk, I want to pivot over to just WebViews in general and sort of web hybrid application development for mobile outside of Chrome apps and outside of what we're doing. So I believe that WebViews are really awesome. They're like ridiculously awesome. I'm in love with them. I find when I say that, not everyone believes me. A lot of people vehemently disagree. I think this is going to be a biased crowd. A lot of you will agree with me, but in other rooms, it's kind of, this is what it feels like. Okay, but let's dissect that to figure out why that is. So this is a timeline of what it meant to be a WebView-based application, hybrid application, starting from the very beginning. So 2008, for about 4 years, it was utter chaos. The first WebViews on iOS and Android were just these ugly black boxes, and it was, It wasn't until 2012 that iOS 6 launched that gave us the first really awesome WebView, I think. It still had a long ways to go, but it had Remote Inspector, and that made a world of a difference. And a year after that, KitKat launched, which is fairly recently, and the old antiquated Android WebView finally switched to a Chrome-based one. But it was a Herculean effort for the Chrome team to sort of have to fit into the existing WebView API. And so it was sort of stuck on an M30, which at the time was already an older version of Chrome. And even then it was stripped down. But it finally had remote DevTools access. And so you can inspect now iOS and Android-based WebView applications as you would desktop web apps. So during those days, WebViews were black boxes. You didn't know what was happening under hood, which was made worse by the fact that they really sucked. And that was made worse by the fact that you had vendor modifications, and especially on Android, lots of fragmentation and slow updates. And then that was made worse by comically bad hybrid applications. Most people who reached for a hybrid app was because they were too lazy to develop a good application. And so, we got what we asked for, I think. So it was hard to argue that they were good. And somebody summarized it well for me. They sent me this photo. It seems somebody's seen it before. So this is what hybrid application development versus native development was until recently, and possibly still is today. On the left, you have this maze of death, but at the end, you get this beautiful castle with a wonderful view, and that was native development for multiple platforms. And on the right, you have this clear path you can stroll through, but who wants to sleep in that thing? But this is what's happening this year, and I'm just super excited. Look at the closeness of the timeline here. MR2 KitKat updated WebView to M33, which was a much better improvement over the previous one. A month later, the Cordova team starts working on this project called Crosswalk, which was done by Intel, and I'll talk about that a bit more. But that brought the M36 Chromium WebView to Android as part of your application. Very recently, iOS 8 launched, and I'm sure most of you know there's a brand new WebView available for iOS now. And they also updated the old WebView for most of the goodness that this one brought. So this is the first new WebView since the very first launch of iOS SDK, which is big news. And it brings most of the Safari goodness to the WebView finally. And just now, Android L is launching, which has a fantastic WebView. And Android L 5.0 is changing a lot of the way native and web interact on the platform in general. So there's all this really cool stuff happening right now. So, specifically what's new in iOS 8 WebView. So JavaScript JIT, first time ever. And I don't actually think JavaScript was the bane of our problems with hybrid applications, but it's nice to be finally on par. So this is good news. WebGL support, which is I was pretty surprised, but that's pretty amazing. This opens up a lot of possibilities. HTML templates and promises support. I feel like a year ago, nobody was talking about this. Nobody knew these technologies. They seemed like they were off on a distant future. And now they are available on every single platform, mobile, native, or mobile desktop, including WebView, which is amazing. And a whole bunch of other support. Speedy support, IndexedDB finally. And Android L WebView. I don't know if anybody's seen the news because it's somewhat recent, but the WebView in Android L will auto-update via the Play Store. which is a first. This means it won't update once a year when Android updates. It will update as often as Chrome does. And the fact that it's through the Play Store signals to me that that will mean on every single Android device, shipping with L, made by any manufacturer, which is amazing. And it has been bumped to M37, and it has all the goodness you would expect from Chrome Desktop now available on mobile, including in the WebView. And then this crosswalk thing. So Intel did something amazing. So the Chromium code base is open source, and there's like this WebView stack, and there's like instructions on how to build your own version for testing or whatever purposes. And they took that and they ran with it, and they said, well, that's just silly. Like, why can't we wrap that in a WebView type interface and just provide application developers with a way to wrap their web assets with a real Chromium build instead of using the system WebView. So it runs on Android 4.0 plus. And it sort of provides what L-Release provides out of the box, so it's not really needed. But for all those older Android versions, which is still 99.99% of Android devices out there, it fixes all those woes that you had and complained about. And in case you thought, well, okay, fine, I could see the bright future, but on Android it'll take 3 years to get there. Well, no, you could do this today. There are some downsides, but there's amazing benefits. And so there's this document, which you can read later when you get the slides, which we've put. So the biggest caveat is there's an 18 megabyte overhead because you're essentially shipping your own browser alongside your application, but that's not all that large. Yeah?
Is that consistent with your next app? Do you have to incur that cost, or can you point to the browser itself that you want to have 2 apps?
Okay, can you share the WebView with 2 applications? It's possible. The downside of that is you have to have a common shared WebView that they download. And so you as an application developer can choose to sort of statically bundle it with your application. So then you know when somebody installs your app, they have everything they need. Or you can choose to send them to the Play Store to download the shared module thing. And Intel has provided both options. But most application developers choose to bundle it because then they have full control over everything. But it's an Yeah, so you have options to get around this. Or just upgrade to L. Okay, so we talked about yesterday, the dark evil yesterday, but this is what I think the future looks like. iOS WebView is on par with Safari Mobile, and Android WebView is on par with Chrome Mobile. And both of those platforms are accelerating really quickly to become truly amazing. WebView is not a black box anymore. WebView is not different. It's not something you have to learn over years of cutting yourself. It's exactly as you expect and as you're accustomed to on desktop, which is fantastic. You can remotely inspect both iOS and Android WebViews. You can do DOM manipulations. You can debug. You can do all sorts of performance monitoring, JavaScript breakpoints, like everything you're used to. Graphics performance problems used to be terrible. Like people couldn't used to be able to get the page to scroll properly. Like these issues are going away. And if you do make one of the fatal sins that will kill application performance, you can now find out why and what happened. And just the fact that everything's equivalent just changes everything. So perhaps you agree a little bit more with me that WebViews are awesome. Okay? However, we are not awesome at making WebView-based applications yet. Okay? So help is on its way. There's a whole bunch of framework authors doing amazing things. Polymer, Ionic, Facebook with React and Flux. So many things were displayed even at this conference of what people are experimenting and how to make it easier for you as an application developer to know how to get started and where to go for help. It's amazing. Like you could spend your entire life just researching how to build web applications because life is changing so quickly for us. But there are more and more resources now as like single de facto places to go to find the answers. And so this is getting better. It's a very interesting time. So I think that we now have an amazing blank canvas for web-based application development. Especially on Android and iOS, which is what we're working on, but on all the platforms. And so now it's up to us as developers to find the right frameworks, put them together, build guides and everything, and just take this to the next level. Native developers have been doing this for years. native apps did not start out wonderful. It took them years to find the niche and find the sweet spot. And so now we just got to take it to the next level and build those showcase applications that will make everybody say wow, and truly get it. So that's where we're at now. And if you're not going to be the first one just a few years from now, make sure that you're not surprised that when everybody else has moved this direction. So thank you, everyone.